Okay, our last ones here, whoops, ignore that page. Our last ones are 87 and 89. Sorry, my book is hard to manipulate under this camera. There we go, 87 and 89. So we've got a prime of pi. So a prime of pi, and then it says that a of x is equal to this integral right here. So if we want a prime at pi, we first want to just find an equation for a prime. So an equation for a prime, if you're taking the derivative of this thing and this is just an x, this is a super easy problem, okay? It's only if this is just an x that this is so easy. If it's just an x, you just sub that x right into the expression, and that is it, because the derivative of the antiderivative just takes you back to this function. You don't have to do anything fancy because the upper bound is just an x. So this is your a prime. And then if we specifically are looking for a prime evaluated at pi, then I'm going to plug the pi in everywhere that I have an x. So cosine of pi is the value that you have on the far left side of the unit circle. The x value would be -1. And then over 1 plus pi, there's not really much that you could do to simplify that any further. All right, 89 is going to be a little bit trickier because that one has an upper bound that's not just an x. So I'm going to copy this on here. So for 89, we want an equation for g prime where g of x is the integral from -2 up to sine of t cubed. Okay, so I'm going to write over here the general equation. So if we wanted, let's say we had an a of x, and this was from a to some function g, and then you had an f of t right here. So this is going to be just the most generic form. So the definition that you guys had in your notes is this. A prime, you start by subbing this upper bound into the function. So you have f of g of x, and then because it's a chain rule, because you have a nested function, you then follow it up by multiplying by g prime. And we technically could have considered ourselves to be doing that here, except the derivative of this upper bound is just a 1. So, you could say, yeah, sure, I'm multiplying this by 1. All right, so here's your formula. We're going to sub everything in here. So if I'm looking at g prime, I first start by taking the upper bound and subbing it into that expression. So I have sine x raised to the third instead of t to the third, and then you finish off by multiplying by the derivative of that upper bound, which would be cosine. So just rewriting so it's in more familiar notation, write it like that. And that would be our expression for number 89. Whoops, there we go.